Okay, it's time to begin. So let's get started. First, like all IETF sessions, I remind you that this is under the note well. If you have, can we have one meeting, please? Uh, Please use the QR code to get the information about the note well if you're not already familiar with it. This is a new addition to the slide. Meeting tips, we will be using Meetico to manage the queue. Please make sure you are all in the Meetico so that you can get into the line if you want to say something. The on-site tool is the one you'll use if you're in the room, the remote one if you're not. These are the links you'll need to participate, the slides, the notes. Thank you, Kirshna, for agreeing to be the note taker, the chat, and the audio stream later. And Meetico the link is on the agenda. We have a very full agenda. At this point, I ask if there's any bashes. We got one speaker who backed out already. We reallocated the time. Okay, then this is the agenda we will follow. If we actually finish all of that early, we have some people who wish to share about some work that they would like to do in this group. So the rechartering discussion, I'm going to pass to Luigi.
So, as you know, we are going for a full recharter. Okay. I tried to start a little bit of a discussion on the mailing list. One of the key points that actually lead to the full recharter was the implementation policy. Okay. We had several exchanges on the mailing list on the right wording to use for the implementation policy. So the key points are: one, we need two interoperable implementation for any protocol specification that comes out from this working group. The idea was also to have a track of the implementation during the evolution of the document, not necessarily when it goes for RFC, but at least not having just a few pointers in a lost wiki page, okay, which is not that insightful, I would say, and completely disconnected. Okay, so what you see on the screen right now is the result of this discussion that we have in the last 2 weeks. Okay, and seems like a convergence on this point, and I would like to invite anybody that has something to add to this wording for the implementation policy to go to the mic, queue up, and share. Otherwise, we take it as we converge. Job?
Job Snyders. I thank you for the summary. I agree with what you've stated so far. And I wish to make a statement for the benefit of the group of why I believe this is an important addition to our charter. The RPKI is now 15-ish years old. Maybe if we look at RC 3779, it goes back to the early 2000s. And in the last few years, we've seen a massive rise in popularity, and the planet as a whole has adopted RPKI as the mechanism to protect the internet global routing system. And this means that we must hold ourselves to a very high standard in terms of specifications that we give to the internet community at large, where we say, hey, this is what we think the RPKI is currently. And those standards must work flawlessly. We should really try to make protocols that have no dead ends or finite state machine issues. The way to improve document quality is by implementing it in code and experimenting together and testing is my understanding the same as yours. And if we skip that step, it always comes back to bite us in the ass. And later on, we're like, oh, gee, I wish we had tested this 2 years ago, because now we need to do a BIS on the document. And that's a lot more paperwork than trying to get ahead of things and before publication, testing the full interoperability matrix. So this might seem like it's more work, but in reality, if you look at a multi-year perspective, this approach, I believe, is less work than testing in the production environment, so to speak. And this approach has worked miracles in IDR, the working group that governs BGP, and has helped that working group tremendously. And I think it will have the same benefits for our working group. It also forces people that have a cool idea to team up with people that like writing code. And this type of collaboration is what makes the standards beautiful. So I think it's not an impediment that to only have an idea but not write code, or to only want to write code but not necessarily invent things, because this type of policy connects both sides of the equation. And I think this change will have material impact on the document quality of SIDROPS. End of monologue. Thank you for your time.
Thank you, John.
John Scudder. I'll start by saying an amen to Brother Job's sermon there. So I have something a little more down to earth, which is, so in that language, so the place where this came from, or ish IDR, it's like everything is peer-to-peer. In this group, there's a lot of stuff that's client and server-ish. In this statement, does one client and one server count as two things?
Good point.
If I may.
Go ahead, Job.
So at least 2 interoperable implementations. And one client, one server is the bare minimum, and it's more than what we require today, according to our current charter. And ideally, like if I were to ship a spec, I'd show up at this working group if I have 4 implementations. Look, this actually works. But that's me. And someone else might be like, well, I'm just going to do client and server and call it a day. And in the working group deliberations, we might point out like, hey, only one client, one server is not that much. Let me add my own proof of concept. Like I'm inspired to add running code to help this project forward. So we should not aspire to do the bare minimum. But yeah, legally speaking, one client, one server is 2 interoperable implementations. And if that situation arises, I would point out like, hey, can we not try and get an extra server or an extra client just to make sure that we fully, grok the protocol specification?
Just for clarification, to be crystal clear, this was also raised on the mailing list. The team made an example about his draft that he has is the client side has an implementation. This is one implementation of the client side that interoperates with the existing infrastructure. Okay, and I said on the email is a nice example. We will discuss when time comes. Apparently, it's today, and it's up to the working group to decide how. For me personally, it's fine. I was more interpreting like I need to client implementations in order to have a choice. But if the choice is we have client server implementation, these are 2 implementations, the server side is existing already and this is fine for everybody, so be it. Are we okay with my last interpretation? Tim?
Yeah, Tim Rijsels, indeed, I did raise that. So I think ideally you have more implementations. It's also what I said in the email. And hopefully we don't need to decide that one client is enough. But yeah, I would go with what Job said, that the bare minimum is to have a client and a server, or if you have one client with multiple servers, that's also better than
So
one
ideally,
client,
we
server.
have multiple of both sides,
Indeed,
but the
ideally
bare
we have
minimum
multiple
is.
clients. But I think, in this point, specific example, it's the draft documents how a delegated CA might migrate from one publication server to another. I don't know if proof of concept code could be done at the level of the RAR implementations. They're a bit different because they have local trust, so they don't work exactly the same way. So to have a full client implementation in that specific case might be a bit more of a challenge. But if we say to the level of the law, it's okay if you have one client, and maybe we can figure out how to at least do proof of concept or a hackathon or some idea of like, we believe that this will work for other clients as well once they get to it. I think that would work for me. And I would use indeed the consensus process in the group to make the assessment of whether that's good enough. Because I think it's really hard to specify that in text, and probably you're going to get it wrong. So to me, it's more important that we consider it.
Okay, thank you, Tim. Rob?
Rob Austin. I would actually encourage going to a hard must be 2 client and 2 server for 2 reasons. One is, to be blunt, if you can't get 2 implementers interested in doing it, it may not be very important. But secondly, the first implementation tends to be done by the person who specified it. And if a large part of the point here is to make sure that the specification is understandable by someone who didn't write it, which means that there needs to be at least one implementation of each part of the protocol by somebody who didn't write the spec. Exactly how to word that here, I don't know, but my gut is 2 implementations of each part of the protocol, and the working group chairs can waive this if there's a sufficient reason.
Do you think that we need more wording to specify this, or we, as Tim said, could be just consensus based? Joe?
To react to Rob, I agree that ideally there's 2 clients, 2 servers, because the first implementation likely is the principal author of the idea. But how we capture that in a charter, if I compare this to other charters, so for instance, the SSH maintenance group or the to be formed plans working group, this wording of 2 implementations is used. And I think it is part of our working group deliberations to understand, like, do we have full coverage of the specification? So to give an example of recent history, we standardized RPKI signed resource checklists, RSC. And one of the implementations was purely an ASM1 syntax implementation, whether encoding or decoding worked. It didn't do cryptographic validation. Now, this by itself, I wouldn't consider a full implementation, but it does contribute towards, like, are we on the same page? So if you combine, say, RPKI client plus a proof of concept implementation that focuses on a particular aspect, an argument can be made that there is sufficient coverage to progress a document. And I also want to emphasize implementations is broad. Like it doesn't matter if it's open source or closed source, whether it's Python or Rust, good quality, bad quality, something you run in production or not. All those things are subjective, and that's not what this is about. It's really, I wrote a draft. Was someone else able to read the draft and understand what I wrote? That is the goal here. And all the subjective things about, is it carrier grade or not? We don't care about that in this context. So I think using this wording and driving towards like, hey, can we get two clients to, if that is the aspect of the protocol, or if there's both client and server, can we get two servers, two clients? And I think if an idea is popular, we'll sort of organically get there because people will be enthusiastic to contribute to something. And if there's lack of enthusiasm, it's worth researching why is this grand idea of mine not taking off? Like, where are the other implementations? So I would suggest let's start here. But if you want to up the number, I mean, I'm not going to stop.
I think that the main point is that we need to be careful that there is not the risk that there is some small group or even an individual that comes up with a protocol specification client side and has an implementation, and we let it through. We just need to be based on the consensus, make sure that this is in the interest of the whole group. I think more than the numbers itself is what we need to be careful about.
Rüdiger Volk. I would like to point out that just looking at the numbers, just asking for one of each side already could be bad, because it could be essentially the same thinking that produced both, and so the quality control for the standard is not achieved. It does not necessarily happen that client and server are developed by the same group or the same conspiration. If that happens, it certainly is not sufficient.
Maria?
Hello. I'd like to add that it's nice to have interoperable implementations, but even nicer is to have two interoperable implementations, which one can take and actually check whether they are actually interoperable and whether they are actually implementations. Because I have seen some drafts like being implemented, being claimed to be implemented somewhere, but I have never seen. I am not like asking for the code. I am asking for the implementation to be publicly available for like evaluation.
Tobias?
So Tobias Siebig, Max Planck Institute for Informatics, and Tuzi.
Speak up.
Pointed then. Yeah, not a good person with microphones. I hope I'm audible. I would like to echo what Maria said and B, emphasize it, because I tend to find weird corner case bugs in things which people have built and which are deployed like worldwide, and just hitting that one feature that hasn't been used. And it's a bit like the same with documents we produce. If we do not have at least two implementations which we can keep banging against each other to see how they behave in all these corner case situations, we might end up with a spec that is specifying something which will fall on our feet like 5 years down the line.
Meaning two implementation even on the client side, you mean? That's the point.
Can you? I lost
Why?
the word.
You want at least two implementations, because if you turn on a feature, you want to make sure that is interpreted in the same way, or the behavior is the same in two different implementations. That's
Yes.
what you said.
Yes.
So you really want, even on the client side, if it's client specification, you would like to have two
Yes.
implementation.
Which ties in with what Job said about interpreting the spec and being able to arrive at the same, well, working artifact based on the interpretation of the spec, regardless of whether you are the one whose brainchild that is and who knows all the nooks and crannies and the things you should and shouldn't do, or if you just read the spec and try to implement it.
Yeah, I want to try to solve this because I feel there is a part that one client implementation is sufficient. We have to make sure that there is consensus. There are other that say, no, even client side would be good to have two implementations for several reasons, like interpretation of the specs and make sure that they work in the same way. I would say that we don't need to define what I just said in the text. However, there is something that we need to agree on and maybe have a consensus call on this. How do we interpret this text on the specific case of the client side? Okay, and because we have 20 minutes left for the charter discussion, I really would like also to discuss about the objectives. I would like to make this call on the mailing list after the IETF, if everybody agrees, and then we take it from there. Okay, Rudiger?
I think it is not a good thing to be very heavy on the process side and to spell out the rules very precisely. The act of pushing a document to IESG is something that happens after a consensus call.
Yes.
And I think it is sufficient. Well, okay, kind of. It might be good to actually explicitly put into the language that the goal of the procedure and rules is that, well, okay, the traditional goals in IETF for the interoperability testing was not to provide implementations to the users, but to do quality control of the standard process. And kind of, it might be a good thing to spell that out explicitly here, rather than going down into the details. And in the consensus for pushing the thing to IESG, the chairs may remind the community about this.
I think maybe I was not clear. What you just said, I think is okay, and also others stated that we are not here to provide production quality code. It's just to make sure that the specs are interpreted in the same way, and different readers may implement the same specification in a meaningful way. That's granted, okay? What I, as a chair, would like to be clarified after this meeting even is just how we interpret the client side, whether we want one implementation that works with the existing infrastructure, or we want two implementation even from the client side. Then we always manage things with a bit of salt, but I don't want in 1 year from now that we waste time on this point trying to remember what we said today here. So I would like to have a real consensus call on the mailing list for everybody to speak up next week. Tim, please.
Yeah, Tim Ruizels. Sorry. Let me not cough into the microphone. So regarding the one client, I did bring that up because I see a risk there where we don't have enough implementations out there, but I do agree that the default rule should be to have two client implementations, at least also in terms of interpreting the draft. If the other implementation doesn't need to be a full-blown implementation that people can use out there, then I think it is already a lot more achievable to get there, even for the delegated CA case. So I'm pretty okay with saying that is what we aim for. I would just, what wondering is, what if there is, in the unlikely event that you cannot get this and the working group still feels, well, we feel this is important work, is there a way to move forward from that? And I think there probably is, because then
The consensus.
you have, but you have to call it out explicitly. You have to explain why you didn't do it or why
Yeah,
it wasn't
yeah.
possible.
Which is part of the second part where we have the implementation details and reasons. Good. So 16 minutes to go, and about the goals, there was not real discussion on the mailing list, and I mean, we don't need to have a revolution and change all the goals that we have in the charter, but it would be good that people in this room that are interested in doing stuff just state what they see as objective in the coming years, right? So if anybody wants to share something to the mic, would be good. It's not set in stone. We will anyway discuss further later on.
Job. I think most of this is good, but standardizing Yang data models seems a quirky detail to include, because does that preclude SNMP MIBs or CDDL? Or I feel like if a Yang model is needed, it obviously fits within the other goals of the working group, and specifically mentioning Yang doesn't seem super fruitful in the charter context. Like the charter is a statement of principles, and I view Yang as just one means of achieving.
I slightly disagree. The charter gives us a scope of work. It's not just principle. Give us a scope, a precise scope, and we need to be sure that the work that we do in this working group is in the scope of the charter, so that principle we do SIDROPS doesn't mean that we are allowed to work on everything that is about security, like BGP-SEC. This is more on the IDR side, you see. So it's not just principles. We need the scope. Now, on the way we wording the goals, maybe we don't need a separate bullet for the Yang data models, but somewhere we have to mention that if we want to include this kind of documents in the output of this working group. And as long as there are people willing to work on this, and since Yang models are pretty useful, I would say let's keep it somewhere. Okay, but this is a personal opinion on the Yang point. But my real point is the fact that the charter is about scope.
Agreed.
And all the authors that want to submit or are have documents already in the working group have to make sure that their work is covered by the charter, and this is in the scope of the charter.
So the fourth bullet point, develop operational solutions for identified issues, in my mind, covers the solution space that Yang covers. And if we move the Yang thing to a milestone where we say, Q2 2026 will have a Yang model for RTR, fantastic. So put Yang in a milestone, I would say, rather than in the charter. Because if we put it in the charter, I would want SNMP.
It's not enough, because you may have several Yang models for different protocol specification that we have in the group. It's just not about one milestone. We need the scope. Let's say the charter covers as well the Yang data models. Somehow, let's forget the working. Now, in the milestones, what you put is from time to time is next milestones. Yang model is this in IETF 127, whatever. And then you have a different data model. Then this is a new milestones, etc., and so on and so forth. You see, so it's really about scoping. Not the Yang model cannot be just a milestone. Milestones are like instantiation of the work that is covered by the scope of the charter.
In that case, I would say it is not beneficial to call out a specific style of technology, knowing that there is things like SNMP and CDDL and other telemetry variants. So restricting ourselves to just Yang
that's a fair point.
Unhelpful. but enumerating all the possible data encoding mechanisms is also unhelpful. So
Fair enough.
I welcome Yang work from people that have energy to drive Yang work in context of RPKI, but that one sentence, I don't think it belongs in the charter.
Fair enough. I see the point on the telemetry part. Yeah.
Rüdiger Volk, I contradict Job, which happens sometimes. I think it makes a lot of sense to give clear directions what to do. SNMP should be considered historic after the workshop 20 years ago. Read RFC 3535, and we follow up workshop from this year or last year. Well, okay. At this time and for the next couple of years, clearly Yang is the modeling technique that is covering essentially everything IETF and internet is doing, and it makes a lot of sense not to divert into various variants of technology. Having a unified modeling technique and unified tooling makes a lot of sense. And yeah, well, okay. I would like to see that if someone comes up and says, well, okay, I desperately want to standardize in IETF GNMI for RPKI, I would like to see the working group chair say, well, that is definitely out of scope, as an example.
Anybody else who wants to add something about the goals? We have, so the charter is on the GitHub, and there are a few pull requests that are pending because I wanted to discuss here before I actually do any action. Doesn't seem to the discussion to take place on the objectives. Okay, we will go over the pull request and after this meeting to propose at some point a revised charter. There are other two things that I mentioned in the mailing list. One is the milestones, but this is just in a certain way dynamic, depends on the real charter, and the wording a little bit, which is stale. It was done years ago, so things luckily evolved, and RPKI is a well-known technology now, well established. But this is neat, I would say, it's not the key point. So unless someone has anything to add, we will move forward. We gain 8 minutes. Going once, going twice. Okay, let's move forward. So, I'll have to take it back from the clicker. Done. Yeah. Then I can share new slide. You have the control. That's here. The next in line is Tim.
Okay, just one thing. As Luigi said, we're going to do a consensus call on the charter text on the working group mail list, but recognize that all standards track work is blocked until we get that charter done.
Thank you. Important point.
Implementations.
You should have control of the clicker.
Yeah.
Right?
I'll just use this. I think that's easier. Oh, sorry. Yeah. Okay. So a word of warning before I start. This is complicated stuff. We have a full agenda. So my aim here is to give everybody an overview of what we've written, give you enough context to see where we're going with this, and enough context to read the document and to have conversations with us. We're here all week. And with that out of the way, let me go to more details. So this, sorry, I keep knocking over the microphone. This document is similarly named to a document that you might have seen, draft by Job Snijders. It's not replacing that, it's actually complementing that, as I'll show in the coming slides. What we're talking about here is a problem, and I can talk for a long time about how we got here. There's no time for that. We can talk over coffee. But we have 5 RAR trust anchors, each claiming all the resources in the world. Some of us use an intermediate CA, like I've drawn here on the slide. RipenCC does that, but that's not a security measure. That's really just a transparency thing. Then resource certificates are issued to members, and they can create ROAs and whatnot. But because all these trust anchors can claim all resources, but it is true for all trust anchors, no matter what they do, even if they wouldn't claim 00 at the top, they could start doing so any day. This means that one can impact the other, right? So issues at one RAR can have an effect in other regions, which is suboptimal. Job et al., I forget who the co-authors are, but no matter, this draft talks about how RPKI client implemented some sanity checks on what trust anchors can actually use in practice. And the way it essentially works is by having a syntax where you can say, okay, for this specific trust anchor, I allow certain resources and I deny others. It's definitely a first step. For example, you might say nobody should be using 10/8 because it's space that you shouldn't, would not expect in any of these. There are more constraints that it can apply, like when there's a policy prohibiting the transfer of resources between 2 specific RARs. It can also express that. The downside of it is that, well, it is an incomplete view with regards to many of the specific resources, transfers, and legacies that happen, legacy space that was registered before the RAR system even, and transfers out of majority blocks, which is difficult to model because essentially you just need to allow everything. Also, there may be delay in following IANA allocation. So what if an RAR gets an additional block? Then people may need to update their software before it will actually accept those resources. So we asked ourselves, can we do better? And this is kind of what we came up with. In a nutshell, well, that's a problem statement again. The proposal that we have been working on is a model where initial resource distribution is assigned between trust anchors. The draft is very generically written, but clearly it is written from the perspective of RARs. We have an initial distribution of resources, and then we have changes after that. And for the most part, all these statements are published outside of the core RPKI repository. I think at this point I'll say it. A simpler model from the technical point of view would, of course, would be to have an authoritative trust anchor on top of the RARs that can just issue whatever they have. That's a simpler model, but this is for sure. But this is engineering around the premise that we don't have that option. If that would change, I think that's a discussion that's not so much technical, but more political. That happens at a different layer. I'm not opposed to that, but I have to work with what we can do. So here we take this approach. Essentially, there are two sides to this. Every participant would have a repository where they publish signed constraints. The key that they use to sign these constraints is, in the current proposal, published inside of an object that is published inside of the RPKI. Doing so makes it clear that this is the key, the constraint signing key that belongs to a specific trust anchor that you know. RDS is a resource distribution state. That's a snapshot, if you will, or point in time that lists the full distribution of resources. RDE is a resource distribution event. So that could be transfers. Transfers could work like this. Semantically, one of the participants can say, I want to initialize a transfer targeting this other participant. The other participant can accept it, after which the originator can say, now we're done. In practice, this may happen very quickly, but you could have a longer time involved here. This would allow for future, this would also allow require changes in RAR policies, by the way, but this would allow for cases where you make RPKI on the receiving end before you break it on the originating side. So this example, a resource is transferred out of the right to CC region or the right region to Aaron, then people would be able to set up their ROAS and whatnot on the receiving end before it's removed on the originating side. There are many, many other cases. They're in the draft. I don't think I can go into that right now because we don't have enough time. But yeah, you do need to think about all these things. Like what if you want to cancel a transfer? What if you want to bring resources into the system or remove them? There's how do you deal with adding participants or removing participants? Those familiar with it might know that there's the ICP2 document that's in the making that talks about how this would work. The goal here is to have tooling in place that supports that process. The goal with all of this tooling is not to make this tooling lead what happens. It's all essentially it is following what is happening in the other space. So if a transfer is published here, that doesn't mean that this is an authoritative statement that somebody wants to make a transfer. The transfer happens in another place. There's inter-RAR transfer policies. People look at it, people check it. Once it's initiated, this is really just a way to signal resources are moving. Similarly, with adding and removing trust anchors, this document does not specify how new participants should be recognized in a policy space. That happens elsewhere. This document talks about if this happens, how do you introduce them? How can this be useful? So again, going back to this model, it can be used directly in relying party software, meaning that they would have to validate the constraints themselves to generate a allow deny list similar to what is currently used by RPKI client. And then, they can apply the constraints, or you can have separate constraint validation software that generates this list so it can be used by software. If these RP software itself needs to do all this validation, that means that there is quite a bit of complexity in the RP software needed, which might be an argument for having dedicated software to do this. Another approach might be, and some of you might be familiar with it, is to have a pseudo trust anchor, let's say, that can take the signed constraints as input, so it understands which resources are applicable to each RAR. And in this case, it would just issue certificates for each RAR, in addition to the trust anchors that these RARs still run. So you could run this for an extended time where you can verify that both models essentially result in the same output. And this can use the sign constraints as input to the process, and meaning that anyone else who is able to interpret these sign constraints can verify that this trust anchor reaches the correct conclusions. You could even run this locally using the same input, and you would arrive at the same output essentially, except you wouldn't have the same key, of course. To do this would require much more thought. It's not that we have a plan to do this soon. But yeah, if you did this, there would be operations around running that trust anchor somewhere. Where are you going to run it? How do you make sure that it's properly run? How do you make sure that it's checked, that it's properly run, etc. And those are all things to consider in future. But the main takeaway here is that we wanted to start with the sign constraints as a model of sibling trust anchors to express where they believe resources are. And there's two possible ways that we see that this can be used in future. And with that, I open the floor for tomatoes, I guess. And which t-shirt? No hard feelings. I'm here all week, not just me, other people as well. So when we get to the details, there's a lot of ground to cover, so maybe more than we have time for here, but we're definitely happy to talk to anyone with ideas about this.
Bob Beck, CA fan. Effectively, the RIRs are CAs. To some extent, what you're saying is, let's make another thing because we overclaim in our certificates. You could always just not overclaim in your certificate. I think you're trying to get that you want to get there via this mechanism. One of the ways to possibly look at that in a publicly observable way that is not reinventing the wheel, I would encourage you to go look at Filippo's Sunlight draft that's used for certificate transparency. And I think you could almost just put this into that. Okay, and it ends up being a log entry for transfer appearance.
I'll talk to you afterwards because I didn't remember the reference, but yeah.
Okay, and I don't think, to flip back to, sure, you could build constraints in clients on it, but effectively, I would say that I think you need to think of those as complementary, and you should probably think of that if the CA is constraining itself, the client should never not believe that constraint, but if the client chooses to make more restrictive constraints, the client should be able to do that. It's up to the client how much they trust you. Not, the CA doesn't say you should trust me this much, the client decides.
Yeah, I don't think that's what we're after, but I mean, in principle, with the resources being part of the API Trust Anchor certificate, the Trust Anchor can claim whatever. So if we restrict ourselves there, then that doesn't help. At least not in terms of security. So this is an attempt for siblings to agree on, well, jointly we believe what. Anyway, I'll talk to you afterwards to understand better what you're pointing at.
Rüdiger Volk. Kind of this is addressing serious problems that at least have been around since October 2017, when the RIRs, without an IETF consensus process, invented the currently used multiple anchor scheme. And the question of making transparent how these RIRs are interacting has been open and not really addressed, and that quite obviously is a big problem. And it is a bad thing that it has taken so many years that you actually start to work on it.
Yeah. For the record, in those years I was working elsewhere. but no, I hear what you're saying. I have an echo.
Let's go. We are over time.
Oh. Well, this is trying to address that in short.
Rob Austin, I'll make it quick since Rudiger already said most of what I wanted to. Tim, I would actually like to give you bonus points for having made this presentation more interesting than I thought. I thought I was going to be standing up here to say, good God, what a mess trying to paper over a complete screw up that we allowed to happen 10 years ago. You've actually given us a path, a really complicated, disturbingly complicated path, but you've given us a path that might eventually get us back to where we should have been 10 years ago. To me, that's the main value here. The rest of this is, okay, you want to document the RIR's internal dysfunction, yeah, whatever, but give us a single root already. But seriously, thank you for doing something better than I was expecting out of this. Appreciate it.
Thank you, Russ. Hello, everyone. I'm Job, and I want to talk to you today about the ERIC synchronization protocol for use with the RPKI. This is a collaborative effort with a number of representatives from our community. To provide some context, what synchronizing RPKI data entails, let's briefly touch upon the data movement of a single day. And I used 3 or 4 days ago, I don't know what time zone we're in, but October 30th, I've analyzed how much objects and how much data actually is moving. At the start of October 30th at midnight, a validated cache contained roughly 475,000 objects. And since then, every second, about 2 new objects appear somewhere in the RPKI. These objects are roughly 2 kilobytes each. And over the course of October 30th, about 175,000 new objects came into existence. The data set, if you concatenate the DER bytes, is roughly 900 megabytes, and it compresses by about 50%. And this data needs to be distributed as fast as possible to about 5,000 validator instances, probably. So this means we cannot use Dropbox or Google Drive to distribute this data. We need something a little bit smarter. Here is a graph of the instantiation of new objects as they are discovered throughout the day. And it's striking how you can see that at the top of the hour, all the systems fire and refresh CRLs and reissue manifests like clockwork. All right. What we're looking at is, despite there being many validators and many publication points, we have to realize that each publication point sort of is a monopoly for the data contained within that publication point. So if a CA chooses to use RIPE's publication as a service, then relying parties must connect to RIPE's publication as a service platform and fetch the data. And I cannot connect to a PNX service to fetch RIPE's data. The system has isolated all these sources of data. And the consequence of some of this is that if a publication server is congested, it delays notably revocation information. And revocation information is very sensitive to delays because all validators must see the revocation before the revocation is acted upon. So in a global scope issue is a publication server being offline or congested. We know we don't see a difference between the two states, but it also may be that one particular validator can reach the majority of publication servers, but not one specific publication server. So again, there is no redundancy in how we fetch the data. And of course, people have made attempts to work around this notion by using multiple A and quad A records, or using a CDN, or hosting RDP in a different FQDN than rsync. But conceptually, data is in one location. And the current protocols have scaling issues that are inherent with the design of those protocols. If we look at rsync, the too long didn't read summary is client and server construct a full list of all the files that exist, and then a subset of that file list is actually transferred as data. And on paper, this looks fantastic because we're only transferring the difference. But in practice, calculating what the difference is between the client state and the server state is very expensive, because client and server need to do an expensive recursive operation of the file hierarchy. And the file list itself, by now, with almost 500,000 files or objects being in the RPKI, is multiple megabytes. So you end up with a client connecting to a server like, hey, buddy, you got something new. And then 6 megabytes later, the client says, oh, you had nothing new. Well, goodbye. See you in 5 minutes, where I'm going to ask again for 6 megabytes. It's not great. Then we have RDP, because smart people are like, rsync, there's going to be issues down the line. Let's come up with a new protocol that overcomes the issues of rsync. And in this sense, RDP succeeded. It doesn't have the same issues as rsync. Good job. But it has other issues. And I perceive as one issue that the client doesn't know what it is downloading until after it has downloaded the data. This is because RDP encapsulates the raw data inside the XML envelope. But the fact that it is encapsulated in something means it's opaque until it's fully consumed. And then the client can throw away 99%, like, oh, I already had that in my cache. And this means that clients cannot avoid downloading data they already had. So you come to me and say, Job, I want today's newspaper. And I'll tell you, that's cool, but you must download yesterday's newspaper. And you'll be like, I have no interest in yesterday's newspaper. I only want today's news. And I'm like, nobody. You have to download yesterday's newspaper. And another issue with RDP is that if there's any failure in absorbing the small differentials, the fallback isn't graceful at all. So you attempt to download, say, 10 kilobytes of data. Somehow the connection is reset or times out. The client will come back like, well, you didn't give me 10 kilobytes of data. I'm now going to download 600 megabytes. This is the opposite of exponential backoff. This is exponential punch you in the face. It is not a good scaling property for protocols to behave in this way. Okay, let's do some measurements. I measured this by using PF, the Berkeley packet filter, but you can also do this with IP tables. And you can match packets generated by a specific Unix user. So I made multiple Unix users, one running an RP with only rsync, one with RDP plus rsync, and I measured over time like how much data is going in and out of these environments. And I noticed that let's call it the handshake. So clients and all servers are perfectly in sync. How much data does it consume to establish that they are in fact in sync? And with rsync, it's currently a few megabytes. And this number will grow over time as the RPKI grows. With RDP, it's much smaller because you can use techniques like if modified since, or and the RDP notification file is quite small. So the handshake, RDP wins. It's smaller. If you synchronize every 15 minutes, rsync is not efficient. You burn about 40 megabytes every 15 minutes. With RDP, it's only 5 megabytes. If you synchronize every hour, weirdly enough, rsync is more efficient. And this is because with rsync, you jump to the latest state, whereas with RDP, you must download all the states, all the intermediate states that have been overtaken by events. So there isn't a best choice. And there's some scenarios where rsync is better, some scenarios where RDP is better. In RFC 7115, section 3, the notion of caches replicating towards other caches was brought up. And this is what the ERIC synchronization protocol is about. In ERIC synchronization, we use a number of time-proven concepts like Merkle trees, content addressable storage, concurrency control through increasing numbers, HTTP, an all-time favorite, and ASN1 because we are SIDR Ops. And all of this is bundled together and a new participant in the ecosystem arises, and that is the ERIC relay. A walkthrough is a client connects to the relay. It fetches an ERIC index that is specific to a particular FQDN. So there's one for rpki.ripe.net, one for rpki.apduck.net. And this ERIC index contains a list of hashes of the partitions. And the client can then fetch the partitions, and the partitions contain lists of manifests, and then it fetches the manifests, and the manifests contain the hashes of the objects. And what's really cool here is that the manifests are an integral part of the signaling layer of this protocol, because you need the manifests anyway to do validation, so we might as well leverage them to make them like dual functionality. If you contrast this with both RDP and rsync, in rsync you generate a list of all the files, but the manifests also contain a list of the files, so there's a bit of information duplicity that in ERIC synchronization doesn't happen. Things to know about ERIC relays: they consolidate multiple publication points into a single relay. So through a single relay, you can access both RIPE and APNIC and ARIN data. Relays coalesce multiple different RPKI transports. So the data into the relay can come through rsync or RDP or whatever. And the relay converts this to a uniform representation where the client, regardless of the original source of the information, can arrive at the latest state. Relays are not reverse proxies. They're not a CDN. These are more like spoolers. And they synchronize to other relays, and a client can rotate between different relays. So a client can connect to, say, 4 relays and send requests off to all relays and use the data that comes back. Relays are not operated by the publication point servers. They can be operated by a third party. Contrasting the 3 protocols, you jump to latest, like in rsync. You only download what's changed, or even better, you only download what's purported to be newer. So with rsync, you download what's changed, but there could be like a replay happening. A replay could originate from like a backup image being restored. And in the ERIC synchronization protocol, the manifest sequence numbers are exposed, so a client can choose like, oh, you have newer data, I'm going to try fetch that and validate it. So that's an optimization. There's no persistent sessions like with RDP. This means that clients can use multiple relays interchangeably. And I think this protocol is efficient, fast, and cheap, and RC 9025 compatible in that sense.
You are less than 2 minutes. Less than 2 minutes.
A deployment diagram. On the left side, you see the original publication servers as we know them and use them today. Data goes into the relay, and relying parties connect to the relay to fetch the data that originated from the publication servers. I think from my measurements that Eric synchronization offers a tangible optimization wherein every type of schedule, Eric synchronization seems to outperform both rsync and RRDP. So, but these are preliminary results and more research is needed. But initial results suggest that a synchronization protocol in this direction will use less bandwidth and less IOPS and therefore cost less money. I have built a server implementation that operates at relay.rpkiservers.org. And I'm hoping others will join this effort and maybe write some client implementations or their own relay implementations, and then we iterate on the document and move it forward. And a thing I'm sort of blocked on right now is CMS content type OIDs. But we have 15 seconds, so maybe. Who is going to run the relays? I have found some volunteers that will be happy to host this. I think the ecosystem would only need 3 or 4, maybe 5 relay operators. So it's not a large number. Those organizations would need to commit to running this for multiple years, but only a handful of relay operators is needed to serve the entire planet's RPKI distribution needs. End of presentation.
So we switch directly to the other since you used, or there is just one quick question from anybody? Quick. No? Okay, let me change the slide deck.
I'll work with you on the OIDs.
Hmm?
I'll work with you on the OIDs.
Thank you. So a side quest originating from the Eric synchronization protocol is something called CCR. Because it dawned upon me like, okay, we have an Eric relay and an Eric client, and there's an rsync client and an RRDP client. Are they actually arriving at the same outcomes? And comparing different validator instances easily, automated in a fashion that is automatically processable, turned out to be a little bit of a hassle. So I came up with what I would say is like the MRT dump of BGP, but then CCR is that concept for the RPKI. And if you're like me and you stare at RPKI data every day and you're curious if your validator instance in Tokyo is doing the same thing eventually as the one in Amsterdam, you can compare the JSON that the validators spit out, but that format is not canonical. Like the ordering could be different or white spaces could be different. So we came up with a different mechanism where we use ASN1 to express the cache's state in a way that it makes it comparable across multiple versions of an implementation or different implementations or different transports. We use DIR because that is what we do in this working group. The CCR files contain multiple segments or tables or in CCR context, we call them states. And every state is like a list of items, and it contains a hash over that list of items. And this allows you to quickly compare whether like the physical shape of the RPKI changed or the semantic shape. So for instance, if a CRL is refreshed, it doesn't change the validated ROA payloads. So you'll see the hash of the physical state change, but not the hash over the validated ROA payloads. And I'll share an example in later slides. CCRs are essentially Merkle trees. Each one of them is a Merkle tree, and CCRs can very easily be converted to JSON. In fact, RPKI client has already implemented CCR, and it has a command line option to flip a CCR file from the binary encoding into something that is easier in, say, R or Python. CCRs are not signed data. Again, it's more like MRT dump or PCAP. It's something that aids as a debugging tool or diagnostic utility. So here is the top level ASM1 syntax for a CCR. You can see that a lot of stuff is optional because this is a flexible format suitable for many types of applications. And it depends a little bit on what you're doing, whether you fill in all the fields or focus on a particular field. I can go through all the items one by one, but I'll highlight two states, the manifest state and the ROA payload state. The manifest state, to me, is like the crown jewel of the CCR. This is where we can hear the RPKI symphony as it rings through the universe, if all is working well. But if things are not working well, this is where CCR also is useful, because we can take two CCRs and compare where is the difference, why is there a difference, and debug the thing at hand. So the list of things, in this case, the things are manifest instances, and a manifest instance is the hash of the manifest object, its size, the issuing authority's key identifier, the manifest number, this update, the SIA, and a list of the key identifiers that are subordinate to the authority that issued this manifest. All these manifest instances must be ordered in a canonical way, and then a hash is calculated over that list of hashes, and that allows you to compare the physical state of the RPKI between versions or between times. So every time somebody somewhere issues a new CRL, this hash value will change. There's another state called the ROA payload set. And here the idea is that we extract the validated payloads from all the ROAs, list them in a specified order, calculate a hash over that, and then you have a hash that represents the current state of all the ROA payloads deduplicated and merged in a particular way. And every time somebody adds or removes a prefix anywhere in their ROAs, this hash will change. So we can differentiate whether there was like maintenance re-signing of things or whether people added or removed ROAs. So this highlights two use cases of CCR, but there is also one for ASPA and one for BGPsec. And as time goes by and more signed object types are defined, we can extend the CCR format. That's what the three dots in the middle mean. So this is an extensible format that we can use in like decades to come. Things you could do with CCRs. So right now, a common workflow for a lot of telco operators is to use something like our PKI client that generates a JSON file. The JSON file is fed into something like stay RTR, and then that's fed to the BGP routers. Now, instead of using JSON as the handover between the validator and the RTR server, the CCR format is much, much smaller in terms of megabytes than a JSON file is for equivalent representation. So that's one use case. Another use case is diagnostics and debugging. Like, is there a difference between these two validators that were fed the same data? You might know I run a project called rpkiviews.org, where I have collected tens of terabytes of raw data. I would really like to convert all those tarballs that contain snapshots of the RPKI at a particular moment in time and retroactively convert them to CCR format, so that researchers, instead of downloading tens of terabytes in tarballs where the format changed throughout the years, can now use an industry standard format to understand this node at that point in time had that view on the RPKI. Other use cases could be that an RER encodes in CCR what they expect to come out of the validator and then compare that to what actually comes out of the validator. So you can compare pre-issuance and post-issuance. You can compare the outcome of different transports, like my rsync validators producing the same results as my RRDP validators, and if not, raise an alarm if the difference persists for more than 5 minutes or whatnot. So I really think CCR is a super useful format for this working group to use as an engineering tool as we grow and mature the RPKI and add or remove different transports, or maybe add or change validation rules, or anything we do in the future. Using the CCR format allows us to more easily compare, did we have the same understanding? Is there a bug in the code? Is there something else going on? CCR can be our common language to help future projects. You can download a CCR file from this URL. Compressed are about 10 megabytes. So this means that if we, archive a CCR every minute, and you do that for 5 years, it will fit in a few terabytes, which is a way better deal than the current approach. And RPKI clients can decode CCRs, and you can interact with that. So next steps. I would like a OID. And maybe we can make like a button where every time I press the button, I get a new OID. I would love for this work to be adopted by the working group and jointly work on this specification. I have running code. I think it's in really good shape and ready for use in a wider audience. But the CCR is not a theoretical dream. We spent a few weeks on implementing this, and it is usable today. Yep, that's it.
Time is over, but we have just one quick question. Is anybody? No? Thank you.
Thank you.
Can you hear me?
Yes.
Thank you. Good morning, good afternoon, and good end time. This is Yangfei Guo. Zhou Liu cannot attend this session today, so I will be presenting on his behalf. Today, I will talk about transitive BBStack. It's difficult, even infeasible, to build on traditional non-transitive BBStack. Okay. BGP security has been discussed for almost 2 decades. BBStack aims for strong path integrity and strong cryptographic protection. However, as of October 2025, there are only 2 BBStack published in the RPKI system. So it is clear that BBStack is the most not deployed since its inception. Why? One of the reasons I think is BBStack uses a non-transitive design. Once any AS on the path doesn't support BBStack, the cryptographic chain breaks, and the adopters don't benefit. This results in a classic chicken and egg problem. No one deploys first because no benefit exists, and no benefit exists because no one deploys first. In short, BBStack has strong crypto, but with weak incentives. But the real world requires an internet routing security mechanism that supports incremental deployment. Even if the path is mixed, early adopters should still get benefits. Our objective is to reward early adopters. Therefore, we aim to make BGP paths transitive, so security can traverse non-deployed areas. We try to extend the native BGP stack to support transitivity by reducing BBStack packet formats, mechanisms, and operations, but with little change. The first one is negotiating capability in BGP open, with version is upgraded to indicate transitive support. And the next is preserving AS path for backward compatibility with BGP. And the last is exploring the earning signatures versus pathlet signatures. BBStack choose earning-like signatures, but the transitive BBStack will choose pathlet signatures. Then we met our question. We discovered that a transitive BBStack cannot be built on native BGP without breaking compatibility. I will explain this gradually. So first, it still needs BGP open negotiation, and that's still use BGP stack packet formats. Routers need to know whether the peer supports transitive BGP. And second, it needs to preserve AS paths because legacy routers still need AS paths for loop detection and routing decisions. If we remove AS paths, legacy routers will break. It indeed affects the deployment. Third, it prefers pathlet signatures instead because in transitive BBStack, the verification chain must traverse non-deployed areas. However, it suffers from some key blockers. The first question is about partial path standing. If we want to facilitate smoother BBStack deployment, we need to ease this requirement. And the pathlet signatures may be a good candidate. The second question is about copy and path attack. We can prove that both earning signatures and the pathlet signature cannot fully prevent copy and path can fully prevent the copy and path attack in transitive BGP. I'm sorry. And the third question is about AS path prepending route server as confederations. This mechanism break verification chains in transitive BBStack. The biggest question is ASD in this example may generate a BBStack path that contains private AS numbers in AS confederations. But if we can remove BBStack support in AS confederation, it won't be a question. And the first question is about route aggregates. RFC 9774 says deprecation of AS set and AS conf set in BGP. So the middle AS won't be able to aggregate two or more paths for the same prefix, but the route aggregates may still exist in the real world. We can set a new community attribute to solve this. And the last question is about compatibility with native BBStack. In this example, SAB supports native BBStack, SC supports transitive BGP, SDF legacy BGP are rare. SG may support BBStack or transitive BBStack or both. SH only supports BBStack. Routers are advertised from SA to SD through BCDEF, and they all send the path except D and F. If ASD supports transitive BPSec, it can verify the whole path except D and F, and it can downgrade to legacy BGP when advertising to ASH. But if ASD only supports native BPSec, it can only verify up to SC, because ASD and F don't support BPSec, and the verification result is invalid. So the transitive BPSec is a bad option to keep compatible to native BPSec in this case. As a conclusion, it is difficult, even infeasible, to build transitive BPSec on traditional non-transitive BPSec if we just keep the BPSec packet formats, mechanism, and operations with little changes. The problem with traditional non-transitive BPSec is not its character strength, but its deployment in practically. We need a new mechanism to protect BPSec paths, to protect AS paths, sorry. So that is not merely extending BPSec, it is redefining scope from perfect security or nothing to deployable, inviolable path trust. We look forward to working with the community to explore a future where BGP security is secure, transitive, and realistically deployable. Any questions or feedback?
Any question?
Okay.
Rob Ostine, with respect, we have been here many times before. Basically, the BGPsec design team could not find a productive use case for islands of security in BGPsec. This is all documented in exhausting detail in an RFC that was published at the time, explaining all the discussions that we'd had. I appreciate the effort, but I'm not sure this gets us anywhere we haven't been to and discarded several times already.
Thank you.
Rüdiger Volk, I'd like to point at work done in the times that Rob was mentioning regarding the feasibility of actually transitioning to BGPsec. Please look up for papers by Sharon Goldberg from 2011. That was a technical and economical evaluation, and you might actually want to check that. Of course, your observation that essentially no data shows up in the RPKI essentially hangs on the fact that we have not convinced major router vendors to implement the BGPsec. Kind of Sharon's paper certainly was assuming that large scale operators would be able to run the protocol on their gear. And as long as we do not get there, of course, it's not feasible.
Okay, thank you.
Okay, thank you. Let's move to the next presentation.
Could you hear me?
Yes. Yes.
Thank you. Hello, everyone. My name is Zweli, and I'm pleased to present our recent work on forwarding commitment BGP, or FCBGP for short. This work focuses on enhancing BGP security through path verification. Today, I will introducing about our prototype implementation, test bed, and deployment experience. Let's start with the motivation behind FC-BGP. As we all know, the BGP protocol, which forms the foundation of interdomain routing, lacks a native mechanism to verify the authenticity of AS paths. While solutions like BGP-SAC exist, they come with complexity and deployment challenges. So we ask ourselves, can we design a more agile, lightweight, and incrementally deployable mechanism? That's the origin of FC-BGP. FC-BGP aims to authenticate BGP route announcements by introducing cryptographic assurance for AS path attributes. It introduced an optional transitive path attribute. In parallel, a real-time warning platform for routing anti-hijacking and anti-leakage developed by China Telecom and Tsinghua University has issued alert on numerous routing, hijacking, and leakage events. Therefore, new H3C in collaboration with China Telecom and Tsinghua University has implemented commercial upgrades to its CR 16,000 and CR 19,000 routers to support FC-BGP. And we present FC-BGP at the IETF 122 hackathon, and we will continue to maintain and optimize FC-BGP in the future. We present FC-BGP to validate the design. We built a prototype and deploy it on the FITI backbone network. As shown here, FITI spans 31 provinces across China and provide up to 1.2 Tbps. Our FC-BGP deployment connects 14 AS after soft upgrades. 31 AS support FC-BGP, while 9 remain as legacy BGP nodes. We reconstructed the Internet BGP topology using root wheels data and replaced real BGP announcements on the test bed. By varying the FC-BGP deployment ratio, we evaluate the route hijackability rate under different partial deployment scenarios. About the experience and the results, we focus on 3 key aspects. The first is a functional test. The FC-BGP prototype fully implements the protocol specification, supports both IPv4 and IPv6. And secondly, FC-BGP interoperates with legacy routers from a vendor like Huawei and the new H3C. Updates carrying FC attributes are transparently forwarded while preserving integrity. And thirdly is partial deployment test. This is our core design principle. Even with only 10% deployment, FC-BGP can protect over 17% of BGP paths. Thank you for your attention. I'd be happy to take any question. Thank you.
We have 10 seconds for a question, if there is any. Oh, okay, thank you very much. Let's move on.
Hello? 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 Can you hear me?
Yes, we can hear you.
Okay. Okay, thank you. Yeah, my name is Yufu. Today my presentation is selectively synchronize the RPK data to routers. Next slide, please. Yeah, okay, sorry.
You have control
Okay.
of the slide.
Yeah. Thank you. Okay. I think the motivation of this draft is that when we deploy the IPv6 only network, is only interested in the IPv6 related BGP validation. So now we have RPK data types such as the IPv4 prefix, IPv6 prefix, and also router key and ASPR. We may be likely more RPK data types in the future. So from the network operation requirements perspective, we don't need all data. So reduce the complexity of the operations such as the alarms from the unnecessary RPK data transmission and avoid unnecessary router resource consumption. And also we have the test for the draft. We ran the Cisco and also when EVV and Vjonas router obtained some performance metrics. So this is the we think the topology diagram for the router network. RPE server supports IPv6 only RPKI and all RPKI data, and also Cisco router and Juniper router synchronize the same data in IPv6 only RPKI and all RPKI data. We can see that this is one router performance matrix results. The first, we think the total number of the full scale RPK ROAs was the 45250, and where the number of IPv6 only routes was the 81333. And the second, the synchronized time, we can see that it is 19 seconds and 6 seconds. So we think that IPv6 only routes achieved a 67% reduction compared to the full scale. The third, that router CPU utilization was 2% and 1% respectively. And also from the memory side was the 42 megabytes and 11 respectively. And also we can see that the router interface bound-wise just we compatible between them, and also both renders showed 0% packet loss. Another router performance metrics results, we can see that the synchronized time was 22 seconds and 4 seconds respectively, and also router CPU utilization was 0% respectively, and also we can see the memory is 42 MB and 11 MB respectively, and also the router interface bound-wise utilization, we can see that it was the 1 MPS and 0.246 Mbps respectively. So we get the conclusion that from the perspective of the operation and the route resource saving perspective, better to selectively synchronize the RPK data to routers, and also better to consider the overnode method to reduce the router side cost. So we also have the optional solutions to help the operators select RPKI data to synchronize. The first one, we think, to extend the SNUM to support filtering data by the RPKI data type. The second is the extend RTR protocol to support the subscription. And the third way is the filtering message by routers. But we think that the first one looks simpler than the second one and the third one. So that's all. Thank you. Comments are welcome.
Job Snyders. Can you go back one slide, please?
Okay.
Forward one slide. The second last slide, please.
Slide 6, sorry. Can you go to slide 6?
Okay. Oh, 6. Okay.
Maybe 7.
7.
That one, yes. Stop, the conclusion,
Okay.
yes. So I agree with your assessment that an approach like you're proposing is simpler than extending the RTR protocol to support something like the concept of subscriptions. Option C, ignore data types you don't find interesting, is something that, for instance, OpenBGP already does today. But from a management perspective, configuring each individual router to ignore certain messages is maybe less nice than using the centralized Slurm mechanism. But in the current Slurm specification, you can apply a prefix filter. And if you wish to only send IPv6 prefix PDUs to the routers, you simply filter out prefix filter 0.0.0.0/0, as I understand it. So the question to you is what you're proposing not already achievable within the current syntax of Slurm? And if not, where exactly is the difference between your approach and what the Slurm format already supports?
I think the first is to think this requirement is meaningful. The second is to choose the optional solutions to resolve this requirement. So I think maybe there are 3 solutions for the requirement. Just one option is to extend the Slurm to support this requirement.
I agree with your overview of the options in front of us, but I think there might be a fourth option that the current Slurm format already allows filtering out specific PDU types if you use the IPv4 0.0.0.0/0 as a prefix filter. So what is the difference between this extension and filtering out all IPv4 VRPs with the current prefix filter mechanism? I don't mind writing this down in an email because, and let me emphasize, I like the outcome you're trying to achieve. My only question is, can this outcome not already be accomplished with the existing Slurm syntax? And if I'm wrong, then we should probably incorporate an extension like this. And if I'm right, then maybe it saves us a little bit of work.
Oh, okay. I will check the Slurm. I will check the Slurm to make sure whether the Slurm can do this work. Back.
Thank you.
Okay, thank you.
Okay, nobody else in the queue. Thank you very much. Let's move to the next one.
Okay, hello everyone. My name is Jorge Cano. I work for LACNIC. And this is a short presentation to show you a couple of projects we have been working on. We have been working in open source projects since a little few years ago. We have been working with Ford Validator as a reliant party for RPKI. It's created in C, it's an open source. We have been working on the second version of this validator with a new architecture, more reliable, a lot of bugs fixed, easy to develop new features, and we're planning to release this for the Q1 of the next year. Testing this project, we came up with a couple of projects to help test Ford, and we want to share with the community. The first one is Barry. It's an utility that generates bad RPKI repositories for testing purposes. The first one is, that you can do is create a description file, description the files you want Barry to create, and then it generates the whole tree for you automatically. You also can override fields, so you can introduce errors. For example, in this simple example, it creates a ROA with a wrong version. Or you can use JSON style description to save some space. And in this case, we are generated a TIA certificate with a validity, dates, and an extension for the IPs and stuff like that. We also support RDAP deltas and snapshots. And this is the second project we have been working on, is Rapport. It's a reliant party tester. It uses Barry to create correct and incorrect repositories and feed into the reliant parties, and check out multiple outputs to check that everything is working fine. So far, it has been working only for Ford, but it can easily be extended to work with any validator. So closing up, here are the GitHub repositories for the 3 projects. We'd like to invite you to test them, to giving us feedback. If you'd like to give a comment. Thank you.
Questions?
I mean, we have 7 minutes left, so I can fill that with compliments and praise for this initiative. I think it's really cool what you guys are doing here. And having observed the trajectory of Ford, I think this approach to engineering is key to making Ford and other validators as robust as possible. So I have nothing but praise for this initiative. And maybe reports would benefit from a CCR integration. You know.
That was what you're thinking that when you were presenting this.
No, but,
it's something to consider. That, right?
I think you. What I really like is that it seems the engineering team made this pivoted from we're reacting to bug reports as they appear in the wild, and then retroactively try and figure out like, what code path was hit today. You can now proactively search for complicated scenarios and replay those complicated scenarios in different validators, see how they react. And so compliments to you and the team, and thank you.
Thank you so much.
Rob Austin, this sounds great. Just one observation. Back in the day when we were still doing the initial RPI implementation, sitting around a table in the terminal room, there were usually 3 players, and one of them was one of 2 guys from BBN who had their own implementation of a CA, but it was deliberately broken. It was a demonic CA. And those guys were twisted. They had an absolutely lovely set of completely demented things that no one in their right mind would ever do. So of course they tried it. I don't know whether or not that code is available. I don't know whether anybody from BBN is still involved in anything like this. It might be worth trying to follow up with them and see if that code base is available, just as more demented things for your test suite to do.
Yeah, interesting. Thank you. Okay. That's it. Thank you.
Thank you. Go ahead.
Hi, Robert here. Just a quick addition. If you invent Barry's friend who will tell Barry what to do, you invent a fuzzer, basically, right? So, and Barry's friend will say random things. So Barry will create those random trees and attributes and so on, and then you can feed that into.
And that's report. That's what report trying to do.
Yeah, I'm just saying that Barry can produce that thing. So if we invent someone to tell Barry what to do, and that comes up with these crazy ideas that, like Rob said, that would be great.
Okay, thank you.
Thank you.
We have 10 minutes left, so I propose that we to accommodate one of the overflow presentation. The first in line is PKI to router protocol over quick. Let me put up the slides.
Hello, everyone. Good morning, good afternoon, good evening, everyone. This is Vishnu, HP Juniper. I might be needing help with the slide deck. Do I have the... Okay, yeah, I have it. Thanks a lot. Okay, am I audible? Like,
yes.
It's fine, right? Okay. All right. So, like, on behalf of my co-authors, I will be briefing up a bit on the RPK RTR over quick grab that's going on, and like majorly like to overcome few of the shortcomings of the existing like TCP connections. So we are working on like how we can mitigate like few of the shortcomings that we have. One of them is like like one of the issues that we have is that like if we have packets to be sent from the cache to the router, and the like head of the line blocking, right? That is one of the problems that we've thought of like to mitigate via this, and that was one of the purpose why we thought of working on the quick protocol. And the major help that we get via the quick is like over a single connection we have multiple streams that can be multiplexed. It can be a unidirectional or bidirectional like flow of data, which I'm going to ponder upon like on the following slides. Majorly like this connection is to be initiated by the router, like indicating in the initiating packet towards cache that, hey, I want to support quick like quick protocol for transferring data packets or control packets with the cache. Along with like the router must be acting as a client here, whereas the cache must be behaving as the server. Now, one thing is to be noted is that whenever a connection comes up, a bidirectional channel needs to be initiated for communication between the router and the cache. And this connection can have multiple other streams, which can be unidirectional or bidirectional. Depending on the packets, we decide as to which stream is to be followed. Like, for example, like if it is control packets, which can be like triggered from either ends. So generally it is a bidirectional channel that is used up. Whereas like if it's a data packet or the end of data PDU, like that is transferred generally like only from the cache. So that will be using a unidirectional channel of that connection, right? Briefing up. So as I was speaking about, right, means these channels will be like divided into two general categories. One will be the control channel, one will be the data channel. Control channel will be generally consisting of the serial queries, reset queries, the control packets that we have, and data channel will be generally transferring. It's a unidirectional channel, and it will be transferring the PDUs from cache towards the router. Multiple stream usage, I already talked about this. Okay, so just briefing up in a diagrammatic fashion, whatever I like explained. So as soon as like the router boots up or like comes up with a like the session, So it will be originating two of the bidirectional channels. Now, one thing is to be noted is that these channels are having their own flow controls. So any kind of like modulation that the router would like to apply on, they can apply it affordably over there without any restrictions. And beyond that, like once these control packets are sent and the router communicates for sync from the cache, these PDUs will be transferred from the cache towards the router via the unidirectional channel that is generated. So this is one of the options. Another is to improve operational flexibility. We can use bidirectional streams for data as well. That is another option that we can have over here. It is just the briefing up on the mechanism that I talked about on a diagrammatic fashion, and that's pretty much like briefing a little bit on it. Any comments, addition on this draft will be always welcome. Yep.
Hi, Jishnu, it's Jeff Haas. So good job in the presentation. If two things I'd suggest is the motivations for why the separate streams are actually helpful should go into the document. They'll help people understand why you'd want to actually do anything other than just simply use QUIC as a bidirectional TCP replacement. And the second thing you need to discuss explicitly when you're talking about this is that the end of data marker for our PKI router. This is important as you're seeing in the 8210 BIS discussions about how do we convince the receiver of the RPK router stream to kick off its reevaluation transactions.
Thanks, Jeff. I'll note this and I'll include this in the draft. Yeah. So just answering your first question, why do we need more streams? It's basically one of the advantages that we have pointed out over the TCP that if we can divide the single connection point into multiple streams, we can have a better throughput and communication, faster rate of data. These are the certain points which we have looked at. But yeah, I'll definitely take your point into account and look further into it, how much we can add. Yeah, thanks a lot.
This is Maria. Hello. I'd like to point out that in my view, the main bottleneck is actually not the link, but the router itself ingesting all the data. And with that, I would very much appreciate getting one stream of things which I would consume one after another and not be bothered by multiple streams forcing me to do more things at once. But this is just my implementer point of view.
Agreed, Maria, but that we can deal on the router front as to how capably we can deal multiple streams on our end, but definitely this is going to help us with increased throughput, right? I acknowledge the point that you've taken up regarding bottleneck, but it is something we need to work on the router front as to how we can reduce that bottleneck that you're talking about.
Well, if the bottleneck is actually filling the data structures, then I have no idea how you wanna raise the throughput. It's like optimizing the data structures, and this is still something which is going to be slower than the TCP, even if you do anything. So I'm not saying being against it. I say it looks from my side as something I won't be implementing with a joy.
Rüdiger Volk, I guess that for some time multiple streams will not be really of interest, but in the longer term, I could imagine situations where you want to decouple the streaming of, say, the AS keys versus the ROAS or the ASPAS or so on, as they might end up in different tables in the routers and the dynamics may be different.
Agreed, really good. So as I was mentioning, the bidirectional and the unidirectional channels, right? Generally, like that is the reason why we have divided, like we have the streams divided as per the data packets and the control packets. Maybe like we can um, we can just separate them out and work accordingly, like as per our need. But all good points. Like I'll take a note and let's see like how we can go ahead with that. And I appreciate like any comments and discussion on this draft as well. Thanks.
Thank you all. Remind you that all standards track work is blocked until we complete the chartering discussion. Please participate. That will be open now. Thank you.